Okay, now let's see this question. This question came in GATE 2014 for 2 marks. The question is an ordered n tuple d1 d2 till dn with d1 greater than equal to d2 greater than equal to dn is called graphic if there exists a simple undirected graph with n vertices having degrees d1 d2 d3 till dn respectively, which means that we have been given a tuple, ordered tuple, and if there exists a particular graph with these degrees, a particular simple undirected graph with these degrees, then it is called a graphic, otherwise it is not a graphic. And they have given 6 tuples and they are saying that which of them is not a graphic, which means that from which ordered tuple a graph cannot be created such that these degrees are satisfied for all the 6 vertices. Okay, so 6 vertices have to be there. Out of these 4, 3 will be such that a graph is possible with such degrees, and 1 will be that there is no such graph possible. You have to find that option. Okay, so in simplest terms, what we will try to do, that we will try to have 6 vertices, and then we will see that is it possible to create a graph with such degrees. So let's say take the option A. Is it possible to have 6 vertices, and is it possible to have 6 vertices simple undirected graph such that each of the vertex is having degree 1? And it is possible. See, for 6 vertices, let's say the graph is something like this. Okay, 6 vertices are there, 3 edges are there, and what is the degree of each vertex? For each vertex the degree is 1. Okay, so it's correspondingly when you sort all the degrees in descending order like this, then you will see that the degrees are like 1 1 1 1 1, right? Okay, so a graph is possible. So this is definitely not an option. We have to find that option for which the graph is not possible. Let's see this. In fact, you can have a graph. I will just show example that you can have a graph with 6 vertices and each of them having degree 2, and it is a hexagon. See, if 6 vertices are there and it is a cycle hexagon, then what is going to happen, that each vertex is having degree 2. So this is also possible. Okay, let's check D. Now see, D it is not easier to check, and because of that we are going to apply a theorem which is called Havel-Hakimi theorem. In Havel-Hakimi theorem, what happens, that we simply write the degree sequence, this ordered tuple in which the degrees are arranged in non-increasing order. So 3 2 1 1 1 0, and what happens is that Havel-Hakimi theorem says that this is a graphic, that an ordered undirected graph is possible from this sequence only if, what you can do is that if you take the first set of degrees, so there are the 3 is the degree of the first vertex, then what is happening is that if you take the first 3 numbers and decrease 1 from each of them. So what they are trying to say is that if you have removed this vertex and it is having degree 2, it means that from other 2 vertices you must have removed a particular 1 degree, right? So that is the way of saying that, but in this theorem you can directly apply that like this. So what you are going to do, you are going to decrease 1 1 and 1 from the remaining after 3, whatever are the first 3 vertices, first 3 numbers, from that you are going to decrease 1 each from those numbers, and then whatever you are going to get numbers, that you will again sort to get a degree sequence. So 2 minus 1 is 1, 1 minus 1 is 0, 1 minus 1 is 0, and these will be as it is 1 0. However, you will again have to sort this in non-decreasing order, right? So again it will become 1 1 0 0 0, and again you apply Havel-Hakimi theorem again like that. In the end, if there is a contradiction, or if it is not possible, or the degree sequence we are not getting a proper degree sequence, then what is happening, that we can say that the initial one itself is not a graphic. However, if we get till the end, we don't have any problems, then we can say that the initial one is a graphic. So that is the way we are proceeding. So again here, using Havel-Hakimi theorem, we can say that okay, this is value is 1, so from one more value we have to decrease 1, so from this we have to decrease 1, so we will get 0 and the rest of them will be 0. And this is a valid graphic. Why? Because you can have 4 vertices like this isolated and all of them are having degree 0, right? So this is a valid graphic, and that's why this is also a valid graphic as per the Havel-Hakimi theorem, right? So this is also possible. Only option left is C, and therefore there should not exist any undirected graph with 6 vertices which are having this degree sequence, and that we can verify using Havel-Hakimi theorem also. Let's say 3, 3, 3, 1, 0 and 0, and this number is 3. So from the next 3 vertices we are going to decrease 1 each, and then we will get 3 minus 1 is 2, 3 minus 1 is 2, 1 minus 1 is 0, 0, 0, and this is already in decreasing order. So we will try one more time. 2, so the from the next 2 vertices we are going to decrease 1 and 1 each. 2 minus 1 is 1, 0 minus 1 is minus 1. Now negative degree is obviously not possible, and here we can see that and 0, 0. So here we can see that we have got a negative number which is not possible. That's why this is a violation and no such graphic is possible, and that's why the initial given tuple is also not a graphic, right? So we can say that there is no simple undirected graph possible with 6 vertices with such a degree sequence, and that's why the answer is C.